you have two options here. You have the challenging exercise or the relaxed exercise. So we'll have about 15 minutes. So that'll be like a break and doing the exercise. The first exercise is reduce. So reduce is one of those methods like map and filter that are core to the heart of functional programming and even kind of pseudo-functional programming, which is what we're doing. And so it's important to understand how to use it. The implementation is tough, but very interesting. Let me tell you how it works. So reduce takes a collection and it takes a callback function. And this function is going to reduce always returns one value at the end. So map, remember map returns the length of an array the same length. Each doesn't return anything. Filter will return based on that truthy test that we pass it. Reduce always returns one function. So what it does is it will call, it does loop though, it loops through the collection, calling that function, and then based on whatever that function returns, it gets passed on back and it gets accumulated. So that function is going to be called each time with the past value of the return of that function and the current value, or in the next value in the loop. Does that make sense? So as we're looping and we're calling this function, previously we always called the function with the current item, index, list, right? In this case, we're going to call it with the previous value and the current value. And take those two values and it's going to return one value together. And the example that everyone uses is addition. Some argue is because reduce is so confusing that no one can figure out how to do anything else except for addition with it. But here it is. So we have a list with two items, 1 and 2. Our callback function is going to be called with the previous value and the current value. So the very first go around, and this is the initial value. You can also pass an initial value. So the initial value will be passed as an argument. You add them together. 0 plus 1 is 1. So sum is now 1. N is then 2. 1 plus 2 is 3. So that's an example of how reduce is used. And here's a more complex example, kind of. So we have an initial value, which is an object, okay? And our function takes result, value, key. So the results, the initial value is the result at first, right? So we start with this. Result is an object. And it says if result at value, value is going to be 1 if the key is A. You guys following? Tell me to stop if I'm going too fast. This is a little tricky. So if, this is a common pattern here to say like, if this exists, then initialize it as 0. Otherwise, do something else. So this says if it exists, or if it doesn't exist, so if result.value is false, it's going to go to the other side of this OR, and it's going to initialize result value, add an empty array, return that, and then it's going to push the key. If it already exists, though, it's just going to return this and then push the key to that. Does that make sense what this line is doing? No? Okay, we'll do it one more time. So what this is doing is it's collecting all of the values that are all of the keys that have the same value. And so what it's doing is it's initializing an empty object, and it's first checking, is this value in our object already? So result, empty object, the value for the first property, for starting here, is going to be 1. So we're saying result.1, does that exist? No, it doesn't exist yet. Okay. So then we're going to go to this side, and we're going to initialize result value to be an empty array, and then we're going to push the key. So result value is 1, is an empty array. So we're creating this first array, and it's empty at first, and then we're pushing the key, and that key is A. And then we'll return that result, right, which is an object that has a 1 and an A inside of it, of a array. Okay? And then we do it again. Same object. This time the value is going to be 2. Again, it's going to initialize that, and it creates this here. Returns the result. Now we have something that matches this one, and the result at value, which is 1, already, it matches this one here. And so we'll just, instead of initializing it, we'll push a key. Okay? And then we return the result. So that's reduce. It's a little tricky. So the challenge, if you want a challenging task, is to implement that under the hood. It has this sort of like accumulation effect where it has a memory and it passes it along every single time. And then if you're feeling like it's late and you want to relax a little bit, we have each write, which is a for each, except for instead of going from left to right, you go from right to left. So it's very relaxed at this point. Yesterday,
seems
that
like
was
you would reverse the array instead of, have a function that starts on the right.
You mean like that's how you would implement it, is you would reverse the arguments?
No, I'm just saying, like, it just seems weird for each right instead of doing for each and just reversing the order of the array.
Yeah, well, if you reverse the order of the array, if you're thinking about like time complexity and stuff, it can be expensive.
Yeah, it can. If it's a huge array, I guess.
Yeah. Yeah. It's just a thing to do if you don't feel like implementing reduce. However, reduce is pretty cool, so I recommend doing that one even if it's intimidating, and I'll walk around and help.